Most of the time, the solar system is made of rocks and fire, dense planets, baked moons, and a star that fuses 600 million tons of hydrogen every second. But moving silently through this clockwork are a few fragile outliers. Dirty icebergs barely held together, so delicate that sunlight can literally tear pieces off them. Those are comets. At its simplest, a comet is a small body made mainly of volatile ices, substances like water, carbon dioxide, carbon monoxide, methane, and ammonia, mixed with rock and dust. Volatile here means these materials turn into gas easily when they're warmed, even hundreds of degrees below water's boiling point on Earth. A typical comet nucleus might be a few kilometers across. Imagine a mountain of dirty snow, but with gravity so weak that jumping off it could send you into space forever. Close up, that dirty snowball is more like a layered, porous sponge. The outer surface often develops a dark crust made of carbon-rich compounds and dust grains, making many comets as black as charcoal. Beneath that crust, ices hide in pores and voids. When the comet is far from the sun, say beyond Jupiter's orbit, these ices are so cold, often under -150 degrees Celsius, that almost nothing happens. The comet is inert, a frozen archive of the early solar system. As the comet falls inward along its usually stretched elliptical orbit, sunlight intensifies. At roughly the distance of the asteroid belt, the surface begins to warm enough that the ices don't melt. There's no air and barely any pressure, but instead sublimate. They go straight from solid to gas. This gas seeps and then jets out through cracks, dragging dust with it. Around the solid nucleus, a vast cloud begins to grow, the coma. It can swell to tens or even hundreds of thousands of kilometers wide, dwarfing the solid core inside it. This is where comets really separate themselves from asteroids and planets. Asteroids are mostly rock and metal. They formed closer to the young sun, where temperatures were too high for most ices to survive. Their orbits tend to be more circular, and they usually stay airless, inert, and visually quiet. Planets, on the other hand, are huge. Their gravity crushes material into spherical shapes and can hold on to thick atmospheres. Comets are too small for that. They stay irregular, potato-shaped, and their atmosphere, the coma, appears only when sunlight is strong enough to vaporize their ices, then vanishes again in the cold outer dark. Once that gas and dust are free, the sun sculpts them into tails. Radiation pressure, the tiny push from sunlight itself, pushes dust away while the solar wind, a supersonic stream of charged particles from the sun, sweeps ionized gas into a distinct, often bluish tail. Both tails point roughly away from the sun, not backward along the orbit like smoke behind a car. So a comet is not just an icy rock. It's a dynamic interaction between primitive ices and the full environment of the solar system. So, when we talk about comets as icy wanderers, we're really talking about time capsules, leftover building blocks from the era when the planets were assembling, preserved in deep freeze and occasionally flung inward for us to study. But to understand where these wanderers come from, we have to step far beyond the familiar planets, into the dim and distant reservoirs that feed them.